All right, so problem 2 is from test 2015, and it's question 2, and has to do with margin error, confidence intervals, and sample size. So to increase business, the owner of a restaurant is running a promotion in which a customer's bill can be randomly selected to receive a discount. When a customer's bill is printed, a program in the cash register randomly determines whether the customer will receive a discount on the bill. The program was written to generate a discount with a probability of 0.2 or 20%. That is giving 20% of the bills a discount in the long run. However, the owner is concerned that the program has a mistake that results in the program not generating the intended long run proportion of 0.2. The owner selected a random sample of bills and found that only 15% of them received discounts. The confidence interval P, the proportion of bills that will receive the long run, is 0.15 plus 0.06. So my margin of error is 0.05. This 15% was the P hat that they found. Please, I just want to point out that this is always P hat, and it is always your best estimate of the true proportion, or if it means the true means. All conditions where inference were met. So consider the confidence interval, 0.15 plus or minus 0.06. And you're like, well, I usually don't think of confidence intervals like that. So I subtract and I end up getting 0.09, and then I add, and I end up getting to 0.21. So that's the way we usually think of our interval, as we think of those two numbers. So does this confidence interval provide convincing statistical evidence that the program is not working as intended? Justify your answer. The 0.15 plus 0.16 interval, or the interval, contains all plausible values from 0.09 to 0.21. So when I calculate my interval, any number within there and including the endpoints is a possible response, which means that 0.2 is a plausible value or a possible value. And because it lies within the interval, we cannot say that the program is not working, right? So we cannot say that the program is not working because 20% lies within the interval. Does this confidence interval provide convincing evidence that the program generates the discount with a probability of 0.2? In other words, is it generating it 20% of the time? Well, keeping in mind what we just said, this interval contains all possible values from 0.9 to 0.21. So we don't know if it is producing at 20%. We can just say that 20% is a plausible value, all right? So the interval contains all plausible values, which means that any value that lies within the interval is possible. For that reason, we cannot say that the program generates discounts with a probability of 0.2 or 20% of the time, as it may be generating discounts as little as 9% of the time or as high as 20% of the time. Just saying that no, it doesn't provide statistical evidence is not adequate. You need to say that it generates other numbers. So make sure you address the fact that it could be generating other numbers. All right. A second random sample of bills was taken that was 4 times the size of the original sample. So that's really important, because as soon as we increase our sample size, our margin of error should diminish. It should decrease, or the width of the confidence interval will get smaller. So in the second sample, 15% of the bills received the discount. So basically, they ended up with exactly the same p hat. So the center of their confidence interval is going to be the same. All right. So determine the value of the margin of error based on the second sample bills that would be used. Well, I like this formula, and it's not on the formula sheets, but one you probably need to note. And I hope to get into the helps on the website. 1 over the square root of new over original, the new sample over the original sample. Well, up here, they tell me that it is 4 times the size of the original sample. So I replace new with 4 times the original. So that ends up with 4 times the original over original, which is just 4 over 1. which is the square root of 4. Square root of 4 is 2. So basically, I end up with a margin of error that should be half as wide. So the new interval would be 0.5 plus or minus 0.03. So my margin of error is this part of the interval, which tells me that my new margin of error is 0.03. Now, you may be saying to yourself, what happens, excuse me, that's going to apply to the next part of this problem. So that would get you full credit. Did you need to show it that way? No, but you did need to show some work as to how you got there. All right. Part C, based on the margin of error in part B that was obtained from the second sample, what do you conclude about whether the program is working as intended? Justify your answer. And this is where if you make an error in part B, or if you're not sure, come up with some sort of solution. If it's wrong, you're not going to get credit for part B, but you can use that answer in part C and still get full credit for part C. So just because you can't do part B correctly doesn't mean you can't get full credit for part C. Please always remember that. So always try to get as much work done as you can, even if the problem builds on itself like this one does. So the new interval contains all possible values from 0.12 to 0.18, which means that 0.2 is not a plausible value. Because it does not lie within the interval, we can say that the program is not working as intended. Because they wanted 20% to be in there, when we increased the sample size, we saw that it wasn't. So consequently, we can make the conclusion that it's not working as intended.